10 years ago, I stood here watching thousands of workers build this giant concrete wall. Today, I'm back, but this time the river is under control. The spillway gates are alive, millions of tons of water are waiting behind the dam, and hidden beneath my feet is an underground world that almost nobody get to see. We are going everywhere, from top of the dam to deep inside the drainage gallery, and even see the massive sediment basin while they are empty. Let's explore one of the most fascinating engineering structures ever built. This project is special to me. This was one of the first major hydropower projects where I worked as a mechanical engineer. Back then, there was no reservoir, no flowing water, no operating gates, just mountains, tower cranes, excavators, and thousands of engineers and workers building something that would serve for generations. Looking back at these construction photographs, it's hard to believe this is the same place. Every embedded steel plate, every hydraulic cylinder, every gate, every piece of equipment had to be installed with tolerance of 2 millimeter. Because once the concrete was poured, there was no second chance. Today, everything is operating exactly as it was designed. Let's see what 10 years of operation looks like. Standing on top of the dam, you finally appreciate its true scale. Behind me, millions of cubic meters of water are stored high in the mountain. This isn't just a beautiful lake, it's stored energy. Every drop has potential energy because of its height. When engineers decide to release that water, it can generate electricity, control floods, or safely pass excess river flow downstream. But before any water reaches the turbine, it must begin its journey at one very important place, the intake. This massive concrete structure is called the intake block. This is where water leaves the reservoir and begins its journey towards the powerhouse. Unlike the spillway, which simply return excess water back to the river, the intake carefully selects water that will be used to generate electricity every second. Enormous volume of water pass through these structures. But before they are allowed to enter, they must pass one very important safety system, trash rack. Just here, the trash racks are installed. But right now, they are submerged in water. The trash racks are installed here to prevent floating debris to enter the headways tunnel. What will happen if trash rack gets choked? That's where this impressive machine does the job automatically. This is called the trash rack cleaning machine, also known as TRCM. Instead of sending workers into dangerous flowing water, this machine slowly travels along the intake. The joint rack lowers between the steel bar, grabs the trapped debris, lifts it out of its water, and place it into this dump truck for disposal. It may not look dramatic, but this machine operates continuously during period of heavy debris, and without it, the intake would slowly become blocked, reducing water flow and affecting power generation. Sometimes the most important machine aren't the big guys; they are the ones quietly doing job every day. So just behind the trash racks or the intake gate, these vertical steel gate control whether water is allowed to enter the hydropower system. During normal operation, they remain open, allowing a continuous flow of water downstream. But if engineers need to inspect, repair, or isolate equipment further inside the project, these gates can be lowered completely. Once closed, the entire downstream system can safely be emptied without the reservoir continuously feeding water into it. Think of them as giant underwater doors and controlling access to everything downstream. Once the water passes this gate, its journey has only just begun. Because next challenge isn't controlling water; it's protecting the turbine from something much smaller, sand. But before we go towards the sand, let's move to one of the most spectacular parts of the dam, the spillway. Today, one of the radial gate is operating. The moment the gate begins to lift, nothing seems to happen. For just a few seconds, the water hesitates. Then everything changes. Water accelerates toward the narrow opening beneath the gate. Its speed increases dramatically. A giant whirlpool suddenly forms on the upstream side. Many people think this whirlpool is dangerous, but in reality, it is completely natural result of fast-moving water rushing towards a restricted opening. As the gate lifts higher, thousands of tons of water every minute surge beneath it. Within second, the quiet reservoir transforms into an incredibly powerful flow. Standing nearby, You don't just hear it, you feel it. The vibration, the spray, the deep roar echoing through the valley. This is controlled power, not nature running wild, but engineers deciding exactly how much should pass downstream. So, flap gate. Just above the radial gate, another type of gates quietly perform a very different job. They are called the flap gates. Unlike the radial gate, which release large volume of water through opening beneath them, flap gate allows water to flow over their top. Each gate is hinged near its base and operated by massive hydraulic cylinders hidden below the gate body. As the reservoir level changes, the flap gate can be raised or lowered to control the upstream water level with remarkable precision. From above, they may appear relatively small, but standing underneath them, you quickly appreciate their true size. One of the flap gate during my visit was partially open, another was fully lowered. This gave us a rare opportunity to see the hydraulic cylinder that move these enormous steel structures. Every movement is smooth, precise, and powerful. Without this hydraulic system, moving gates weighing hundreds of tons would be impossible. So let's talk about the sand. Mountain rivers constantly carry millions of tiny particles, sand, silt, small stone. And if these particles enter a turbine spinning hundreds of revolutions every minute, they behave like sandpaper. So before the water can continue towards the powerhouse, engineers must first remove as much sediment as possible. That is why we are heading to one of the largest structures inside the project, the sedimentation basin. Normally, these enormous chambers are completely full of water. Very few people ever get to see them empty. Fortunately, during my visit, they were trained for inspection. That gave us a rare opportunity to see exactly how they are built. The idea behind this basin is surprisingly simple. When water flow quickly, it can carry heavy sand particles, but if you slow the water down, gravity takes over. The heavy particles settle into the bottom, with the cleaner water continue forward. It is the same principle that caused muddy water in a bucket to clear if you leave it undisturbed. Except here, everything is happening on a gigantic scale. Thousands of cubic meters of water move through these basins every second, yet the engineering principle remain exactly the same. Slow the water, let gravity do the work, collect the sediment before it reaches the turbine.